to request to share Dr. Dungana to share his screen and start presentation. Thank you so much.
Thank you, Rudraji, and thank you, ANPA, for providing this opportunity for me. So I'll be sharing my experience on developing some of these labs that we are developing right now. And we use some of those labs for the summer, and they're gonna go in full phase during the fall. Although these labs are developed for the in-class use, but we are somehow optimizing this for the online as well. So if some of you are wondering like what this guy is writing here, besides this PhD degree, these are basically in-service training I received. One from the Central Department of Education, Tribhuvan University. It was around 1998. That is PGDE, Postgraduate Diploma in Education. And basically, it helped me to actually understand that teaching is not just presenting content, but it is also art of presenting the content. So that interest developed, and then I got another opportunity while teaching here in University of Colorado, Denver, and I jumped into another 1 year long training. So these are my degrees, and those degrees plus right now I'm serving as serving in a curriculum committee in our department. So in that capacity I'm developing these labs. I got opportunity to develop these labs. So some of the material I have developed for these labs, you can find them in this YouTube channel, Raw Physics. You still go there and watch those videos before they come to the lab. Okay, and I'm not active on social media, but sometimes I share some of my let's say photos and some let's say teaching materials. So if you are interested, you can visit those sites as well. So basically, I'll first start with the survey of the goals different universities uses to teach introductory physics labs, and then I'll talk why I am focusing on developing a skill-focused lab rather than the content-enforced labs, and then I will talk about how am I developing these skill-focused labs. And then finally, I'll present 2 examples of these labs that I have developed. And these labs are developed from the inspiration from the Cornell University. They are also actively developing these kinds of lab, and I am kind of studying what they are doing, and I am modifying them as our need in our department. So I usually like to interact with the audiences, so that's why I have brought this question. So what should be the goals of intro lab courses? What do you think? Okay, so if you like, you can indicate those by, let's say, showing your finger. Don't show the middle finger, but other fingers fine. 1 for the number 1, 2 for the number 2, and so on. Okay, so or you can also type that on the chat if you like. Okay, I'm gonna give around 15 seconds for that. Let's see how many of you are interested getting involved in this one. So let's see. So somehow I don't see the videos, but and of course all these videos are turned off. So if you can, please try to type those. Okay, and so far based on the chat, what I see is there are these varieties of options, not just one. There is no agreement in single goal. Okay, so that's what got out. That's what I got out from here. So let's look at another survey. And this survey was done by the Center of Science Education, Tata Institute of Fundamental Research in India. So I'm bringing this because we fellow Nepali physicists participating here, maybe that could be of interest as well. So they ask about what kind of goal physics lab should have. So they ask that kind of a question, and there are some responses, just like we saw in our session, like we had these different views. Similarly, we see these wide varieties of views, and these are only 10 out of 50. All those, if you're interested, you can find in this reference you see here. So what does it mean is that there is no single agreement on what should be the goal, and of course we are not just focusing on a single goal. And there are some goals from the American Association of Physics Teachers. In short, it's called AAPT. So I like to skim through these, and what we see is first of all, we see there is this emphasis on modeling, designing the investigations. And then after that, it moves to the data analysis, and then goes to the physics concept. So help the student to master the basic physics concept. So what does it mean is we are seeing this mixture of different types of goals. And the lab we've been using to teach our students in different universities basically lines up with these kind of goals that are the mixture of, let's say, learning the concept versus learning the skill, data collection, data analysis, and so on. So there is no surprise. Okay. And then later in 2014, what happened is the same organization came up with this different recommendation. And this committee consisted of like three fellow members from the different universities of Colorado. And one, Randy Tagg, you can see in the bottom. He is my colleague in my department, and currently he is developing labs for the seniors and the juniors undergraduates. And I am focusing on the lower division intro physics labs. So here we see now there is no content enforcement kind of goal here. Okay, so if we look at the details, that's what we find is there is a collection, analysis, and then developing worldview or model, something like that, but we don't see the enforcement of the content. So that's what we see here. So now it also emphasizes on the uncertainties that was missing on the previous part. Of course, that could be the part of the data analysis, but now it emphasizes and specifically that uses that word. Don't forget about the uncertainties to let's say tell the validity of these data. So here is a survey, and in this survey what they do is let's say they look at the final exam performance in the final exam of the students who took the lab class versus who did not take the lab but they take the same physics course. And they chose the question that was like related to the concept covered in the lab as well. And then they did the study and they presented the finding. So now the question is, what do you think what they may have found? Okay. So here is a question for everybody here to the participants. Okay. So what do you think was the major impact using concept in the lab was the major impact on the performance in the physics lab? Okay. So that's the question here. Major or some or no impact. So I am seeing mostly one. and there is 2 as well. 1 again, 2, and so on. So mostly 1 and 2. So now here is the result. Surprise, surprise. There is no impact at all. Okay. So those students who took lab, for example, in the lab we focus, let's say, principle of conservation of momentum. And if the same question was asked to the student who took that lab versus who did not take the lab, the performance was similar. There was no difference statistically. Okay, there is no difference. And so that's the surprising result. So all these things motivated me and our colleague in the department that let's not focus on enforcing the concept of physics in the labs, rather focus on developing the skills of analyzing data, and then analyze data and then get the let's say result as if a scientist does in any discipline, does not have to be a physicist. Okay, so here is another study. We see the same result. There is not major impact. Okay, and so these are our goals. So our department has lab development committee, and committee decided with these goals. With these goals in mind, I have started developing labs. Okay, and since we are just focusing on the skills, what happens is we don't have to use fancy equipments. We can just use simple equipments like pendulum. For example, the lab I am developing right now, I use pendulum and use that for 3 different sessions, 3 labs. Okay, so let's look at how does the example lab look like. So now if you look at the heading of the lab, it simply says compare 2 measured values using the uncertainty. So it's skill focus right there. So traditionally we may say, okay, find the period of the pendulum or something like that, or compare with the value, something like that, but we don't do that. So right now what I'm doing is I'm writing the learning goals there, and I'm also telling them why you are doing this experiment. So right there. Okay, and then after that, what is it? So now the question, another question for the audience is, okay, so now I showed you these 2 things. First, there is title with the goals, and then there is motivational, let's say, sentences that, let's say, hopefully motivates them why, to do that lab. So now there is question, what other elements do you expect in this lab manual I'm writing? So please go ahead and you can start typing the numbers. And you can put multiple if you like, multiple numbers separated by comma if you like. Okay. So I'm getting 5, 4, 1, and 4. And 4 again, and 4 again, and number 2, and 1 to 5, everything. Oops, they kind of contradict, but anyway, and number 4, and so on. And now, what I'm doing is none of the above. There is no procedure in my lab manual. There is no data table to fill. There is no formula for the pendulum, and so on. So there is none of those things that you usually expect from a traditional labs. Okay, so there are none. So what do they do then? So for example, we give them a pendulum and then say, okay, go ahead, time the period of the pendulum, starting from, let's say, at 10-degree amplitude and 20-degree amplitude, and see if you get the same result. And these are not actual results, by the way. These are for the, let's say, I made those for pre-labs. Okay, so here is another question. So looking at this, A and B, and of course the second term here is the uncertainty in the measurements. Okay, so let's suppose a group A came up with that value and group B came up with the another value. So now based on that, do A and B are they same or they are different? So that means what does this observation telling us? Whether the period depends on angle or not. Okay, what does this result telling us? So now for you audiences, okay, participants, so if you think they are the same results, then type 1. If you think they are not, then say 2, okay, and so on. So I see 1, I see 1, I see 1, and I see all of them, I see 1. So looks like we are all experts here. So yes, by looking at the uncertainties, for example, if I were to just visualize that, what we see is there is significant overlap in the result. Okay, so that means although the value 1 and 1.6, they are very different based on the uncertainty. When we take account of the uncertainty, those results are statistically same. They are not different. Okay, so that's what this is telling us. So what does it mean? So it's telling us it does not depend on the angle. So now what we tell them is go try to find out to reduce the value of, find a way to reduce the value of that uncertainty. Uncertainty looks too large. That's what we say. Okay, so students go and then somehow they come up with a different result. Okay, and so what's that process in this case? So what we do is we say, let's say, make the comparison and look at your result, what the result means, and then go back and then redo the experiment, and then come back and make the comparison again, go in this cycle. So that's what we say. Okay, so what happens then? Let's say this is the critical thinking. If you are thinking what is quantitative critical thinking, if you are, let's say, wondering what quantitative critical thinking means, this is what quantitative critical thinking is. Okay, it's the ability to make decisions based on data with its inherent uncertainty and variability. So they can judge the validity of data. Okay, so that's that. Now, let's say they went and then, let's say, rather than just measuring, let's say, just one period, time for one period, or one oscillation, I should say, they measured the time for 10 oscillation and then found the period from there, and that reduces their uncertainty. And when the uncertainty gets reduced, what we see is now these are two different values. Indeed, they are not overlapping as we saw. So now, and there is a mathematical formula they can use, and these are actual data. When we do that kind of measurement and increase the number of periods and then reduce the uncertainty, what we find is indeed we see those values are totally different. So what does it mean? Then at that point we tell, okay, if you look at the book, most likely you'll see the book tells you there is, the period does not depend on angle. It's not amplitude dependent. You don't see angle in the period usually in the books. Okay, and at that time they haven't gone through those, let's say, derivation of the period and so on. So what does this mean? What's the message we are trying to give here? Twofold message. One, first, recheck your data. Even if you think you got the valid results, just like, for example, in the previous result with large uncertainty, what we found was that, okay, the values are same. They were not different. And that is, that is what exactly usually the textbook says. So they may say, okay, yes, we found the result and the result agrees with the theory. Okay, we are done, they may think, okay? But what this is telling us that if we be careful, then we may get different result than what we expect. And then that may lead to new discovery. So this is, of course, just an example, but that's how we are using this kind of lab. So lab doesn't end by just getting one result. Okay, that's not where it ends. That's where the main phase of this lab begins. And of course, we haven't run this lab, fully, so I don't have results from me, but similar, it was done similarly in Cornell as well. So for example, this kind of conclusion they get from the student. So for example, they can construct knowledge by refining their result, and then sometimes they can discover a new thing here, even in this with this simple result. So we try to choose the labs that from the surface they may look obvious, but when you very careful, in that case you may get some surprising result. Okay, so now in physics 2 we mostly focus on developing models. And again, here for example, I'm using electromagnetic induction as an example, but the main title is creating a mathematical model. So that's how we are focusing on the scale. Okay, so again, goals are there, and their motivational statement is there. And then traditionally, yes, I'm pretty sure you have done the electromagnetic induction lab, you have taught the electromagnetic induction lab. So what happens? Students take some data, the setup usually is provided, and then the table is provided, they fill that, and then they calculate the percent difference and say, okay, based on that percent difference, they may say, okay, I got good result or not so good result. But so how am I doing differently here? Okay, so in this case, what we do is we show them a demonstration. So we, let's say, move a magnet through the coil, and then show them, okay, there is deflection in the voltmeter. So that means voltage is being developed. So now what do you think? What factors affects that? So you didn't have to think about that and come up with the list of the elements that determines the voltage, for example. And then what happens is once all the lists are given, then we assign those particular elements to each group in the lab, and then they do their own investigation. Okay, so for example, one student may have gotten, let's say, how does the number of turns affects the voltage, for example, production of voltage, everything else keeping constant. So they get the data, they make a plot, and based on that they come up with the model, for example. So they have data, and then what happens is they use this data to model it. So, okay, so they model it. Okay, and then what happens? They all come together, and then what they do is they combine that model and comes with the empirical relation. And once that is done, what they do is they retest their model, see if that model works by designing another experiment. Okay, so how are we making them work interactively? How are we making this lab interactive? So we give them pre-lab question where they go through them and interact with that question first. So that means they interact with some of the main concept of the lab we are doing. And then the main interaction happens inside the lab. So there is group discussion, they make the plan, and they write the procedure here. Okay, so instructor and any learning assistants, they basically act as a facilitator. Okay, and then they document everything in the lab notebook. Okay, so that's not a new thing. So anyway, so in conclusion, that's my conclusion. Okay. So lab designed to reinforce the content are not achieving this goal. So why bother doing that? Rather focus on the skills. And that's what we are doing. Okay. So next step, we like to test the effectiveness, effectiveness of our way of doing the lab. And there it is. Thank you, everybody.
Thank you, Dr. Dungana. That was outstanding presentation. Very clear, very nice. So, audience, if you have any question, I would like to please unmute and ask maybe one or two questions.
Yes, Professor Kafle, thank you. And Professor, I have one, actually, myself, Madhav. Can you hear me?
Yes, please. Dr. Gimine, please go ahead and ask question, please.
Thank you very much for the very nice talk, Dr. Dungana.
Yes, I am here. I am listening.
Yeah, please.
But
We need.
yes, go ahead.
Yeah. We are listening to you. Please go ahead and ask question. Probably you are muted. Okay, 1 second. Okay, let me unmute. Okay, 1 second.
Sometimes you have to disable the video so that the sound is clear.
Okay, I think Sunita is there. Okay. Oh, yeah. Dr. Gimine, please ask question. You are unmuted. You are good. I think there is some kind of problem. While we are waiting for him,
I mentioned that lab is not very much essential in the context of research. If that is the case, I somehow disagree, because basing on the lab, we get some sort of idea, and basing on that idea, we go further and try to understand what is the main realm of physics. So that I felt a sort of when I go out also. If I don't do lab work and I go out and I don't have any sort of concepts that what should we do. So in that sort, maybe I little bit disagree with what you are saying.
Yeah.
Please clarify about that.
Yeah. Thank you very much. And I totally agree. Yes, lab is essential. Lab skill is essential. What I'm trying to say here is that labs that's designed to verify the physics law, they are not helping to learn physics. Okay, we need labs, of course. We need lab. We need those skills. I totally agree with you, and that's why we are focusing on developing lab that focuses on developing skills rather than proving the, let's say, conservation of momentum or period of the oscillation of pendulum or something like that. Okay, so we pretty much agree. I think there is some misunderstanding, just that.
Thank you. That's very much very nice. I agree now.
Thank you.